consider z is cosine theta plus I sine theta, show that the real part of 1 plus z over 1 minus z is 0. So let's consider 1 plus z over 1 minus z, which is 1 plus cosine theta plus I sine theta and 1 minus cosine theta minus I sine theta. And to understand what is the real part, what is the imaginary part, it must be represented in the form something without I plus I multiplied by something also without I, so I must be only here. So we need get rid of I in the denominator, and to do that we multiply the numerator and the denominator by 1 minus cosine plus I sine to get a formula a minus b, a plus b, plus I sine theta, and you can see we get 1 plus cosine theta plus I sine theta (1 minus cosine plus I sine theta), and the denominator becomes 1 minus cosine theta squared minus I sine squared. I squared is -1, hence it becomes plus sine squared theta. And hence the real part or the obtained result, the denominator remains the same, but in the numerator we need only terms without I, because we need the real part only, and we can consider as multiplication 2 by 2, and we can see that we can get the terms without I only when 1 plus cosine is multiplied by 1 minus cosine. 1 plus cosine is multiplied by 1 minus cosine, and when I sine is multiplied by I sine, because I squared is -1, so it becomes minus sine squared theta, and hence it becomes, it's again a formula, it's 1 minus cosine squared theta minus sine squared theta, 1 minus cosine squared plus sine squared, and it's the main trigonometric identity, so it's 1 minus 1. It would be better to write this, not write directly 0. So it's 1 minus cosine, and it's clear that it's 0 as required. And that's all for this question.